water. What you use lime water for? It is what? Carbon 4 oxide, so that you have a byproduct of calcium trisulcarbonate 4 and your water. So lime water does not have affinity for oxygen, therefore option A is cancelled. Then option B, also you can use caustic soda, because caustic soda has affinity for what? Carbon 4 oxide. Caustic soda is sodium hydroxide. That is caustic soda and lime water. We use these two substances to remove CO2, because both have affinity for what? CO2, not oxygen. That is why B is also not correct. Then C, pyrogalol solution. That's alkaline pyrogalol solution. That one is suitable for oxygen. Then slate lime. Slate lime is also not. Slate lime is also the same as this, but the only thing is that this one is a solid, while this one is what? A solution. So it's also can be used to, because of the affinity for carbon 4 oxide, not oxygen. So the suitable option here will definitely be what? Option C, which is pyrogalol solution. Question 2. The nitrogen obtained from air has a density higher than the one from nitrogen containing compound, because one from air is contaminated with. Nitrogen obtained from air has nitrogen, oxygen, carbon 4 oxide, then rare gases. Take note of that. Rare gases or noble gases. While the ones obtained from nitrogen containing compounds will definitely have nitrogen, oxygen, carbon 4 oxide, minus rare gases. Minus rare gases. Minus rare gases. Rare gases are not in that very one. So simply because, so why the nitrogen obtained from air will be more dense than the one obtained from nitrogen containing compound is simply because of what? The involvement of what? Rare gases. So let's say our option. Option A, oxygen. Option B, rare gases. Option C, carbon 4 oxide. Option D, water vapor. So the answer will be what? That is option B, rare gases. What makes the difference is the involvement of what? Rare gases in the one obtained from air. But the one obtained from nitrogen containing substances or compounds will not have what? Rare gases. So that is why option B is the answer to question 2. Question 3. The constituent of air that acts as a diluent is, I have talked about this earlier. So what's the constituent of air that is used as a diluent is what? Nitrogen, simply because it is employed in the chemical industries where you have it, where you have its operation as what? A diluent, just such as making fertilizers, nitric acid, which is a solution. So we use nitrogen as a diluent in chemical industry. So definitely answer to that very question will be A, oxygen. No, oxygen is a kind of substance that ensure oxidation, not as a diluent. B, nitrogen. Nitrogen is correct. C, carbon 4 oxide. Carbon 4 oxide cannot be a diluent. D, because it's the carbon 4 oxide is what? Is an acidic oxide. Then D, noble gases. Noble gases do not even react at all. So D cannot be option, cannot be correct. C cannot be correct. The answer that will be suitable here is option B, which is what? Nitrogen. Question 4. Which of the following pollutants is associated with brain damage? A, carbon 2 oxide. B, radioactive fallout. C, biodegradable waste. D, sulfur 4 oxide. What leads to the damage of the brain is as a result of what? Incomplete combustion of what? Oxygen. Take note of that. And complete combustion of oxygen, when carbon undergo complete combustion, you have CO2, which is carbon 4 oxide. But when carbon undergo incomplete combustion, then you have what? CO. CO is very unstable. and in no distant time it affects. In fact, this CO, apart from the fact that it can lead to brain damage as a result of the fact that it combines with our hemoglobin and therefore cuts off oxygen supply. So in that situation, in no distant time, the person dies. So apart from the fact that it has the effect of killing a person, it also leads to the malfunctioning of the brain. So the carbon dioxide has two negative effects on human body. Apart from the fact that it's combined with our hemoglobin. You know that hemoglobin is transport oxygen. So when it combines with the hemoglobin, what it does is to cut off oxygen supply. And you know that distant time, when a person is deficient of oxygen, human being dies. Also, it has effects of also affecting. It has a negative effect on the brain because of the fact that it's as a result of what? Incomplete combustion of what? Carbon that leads to that and leads to what? Malfunctioning of the brain. So automatically, carbon dioxide is a suitable option in this regard. So option A, you have carbon dioxide, which is the best option. Option B, radioactive fallout. That one has nothing to do with that. C, biodegradable waste. It has no correlation with brain damage. Then D, sulfur dioxide. That one is used most. It's an oxide of non-metal that is employed when you in the formation of acid, because it's combined with water to form acid. So it's not a solution here. So definitely the only suitable solution in this regard will definitely be option A, which is carbon dioxide. Question 5. The condition required for corrosion to take place is in the presence of, we know that corrosion, what brings about corrosion is as a result of what? Moisture, and corrosion is brought about by what? Moisture and air or oxygen. Take note of that. That's what brings about corrosion. That is why when iron rust is a commonest method of corrosion, or something that corrodes that we can easily see in our environment. And when iron rust, it becomes this. So this is it. That brownish color you are seeing is a result of the formation of this compound. So automatically, what leads to that is the intervention of moisture and what? Air or oxygen. So let's see our option. Option A, water and carbon dioxide and oxygen. No, that one is out because of the involvement of carbon dioxide. B, oxygen and carbon dioxide. No, oxygen is there, but carbon dioxide is not there. C, water and oxygen. Yes, water, because moisture is water, then oxygen is also involved. Then D, water and carbon dioxide. That one is also out because of the involvement of carbon dioxide. So the only suitable option here will definitely be option C, which is water and oxygen. The next question. Which of the following noble gases is commonly found in the atmosphere? The most stable noble gas that we have is argon. Take note of that. The most stable is argon. So that is why it is the most abundant noble gas in the atmosphere. So let's see our option. A, neon, out. B, helium, out. C, argon, correct. Then D, xenon. So the option here is, the correct option here is option C, because argon is the most abundant noble gas in the atmosphere. Question 7. Iron can be protected from corrosion by coating the surface with A, silver, B, copper, C, zinc, D, gold. What they are testing here is reactivity. And you know that reactivity, according to reactivity series, the elements or metals that are above a particular one will definitely be what? Will definitely be more reactive than that. And when both of them compete in solution, they will nullify the presence of the one that is lower. So that is what activity series is telling you. What am I trying to say? If, according to the trend popular scientists can make a zoo in thin, low, humid countryside, more, that's mercury, more satisfactory, silver. Popular scientists can make a zoo in thin, low, humid countryside, copper, more satisfactory, gold. Gold is the last on the activity series. So if you look at this, as you are coming down this trend, the reactivity decreases. Take note of that. So if two ions compete for discharge, let's say this and this, it means that this one will easily corrode, because this one will be susceptible to corrosion compared to this, in relative to this. So that means that is the significance of what? Their activity series. This one will be susceptible to corrosion in relation or relative to this. So in that situation, let's see what we are given. So according to that question, so this is the concept that we need to answer this question. So the question is telling us that iron can be protected from corrosion. So if iron is going to be protected from corrosion, you have to coat it with elements